Hello, this is Dan Allford with Arc Specialties.
And Zachary Freeman.
I always tell Johnny the four most important things in a welding video are the big picture, the close-up, the arc on, and the smoking part. We're going to get all four of those, but I'm really delighted with this machine we built. We've been building hot wire cladding systems since the early 90s. Traditionally, we've always rotated the part, then we move the torch relative to the part. This goes exactly the other way. We're using a big robot, and then we've added a 7th axis with infinite rotation. This is Zach's baby.
Yeah, so I've had the pleasure of working on such a complex system. It's a lot of fun, a lot of complicated math, but I won't bore you with all of that. But basically, myself, on just a pendant like this, I have full control over, I think we're up to like 12 different axes, and we're able to coordinate and sync all of those up together and put that control onto a pendant that a customer who's used some of our other machines is familiar with. So from the robot to the RTU, that 7th infinite rotation axis, all the way down to the actual wire positioning we have control of. So it's a really cool system.
We put a whole lot of new technology into this one, and that's why we're going to move over to the close-up and show you what happens down at the end of the torch. So we're at the business end of this robot now. This is the welding torch. And so the whole point of this exercise is we don't need to rotate the part. We can actually rotate the torch with this infinite axis. Zach has it set up for adaptive control. It'll follow the contour whether it's following it down or up. But what's really cool about this one is it's hot wire. And hot wire is a way to improve the deposition efficiency of gas tungsten arc welding. By using hot wire, we can go up to 12 pounds an hour, which is a tremendous improvement over cold wire technology. Here's the problem. With hot wire, you have to impinge on the center of the molten weld puddle. That's a critical variable. Traditionally, you set this once, and then if you have cast or helix in the wire, you've got a problem. Zach's got a better method.
Yeah, so like Dan was saying, we have a couple stepper motors here which allow us to locate in real time the actual wire position relative to the molten puddle. So even changing any of your variables on the fly, such as amperage or stick out, volts, we can do all of that already on any of our other machines, but that also changes the shape of the puddle itself. And so typically you would have to stop, and there were these copper tubes that we would bend into location, and like Dan said, generally you set it and forget it, but that's not always the case. And now we have active control, so if I'm changing some of the weld parameters on the fly, I can also change my wire position without the need to stop the arc and reorient and start again.
I think this is a game changer. So often I'll be watching one of our welders working, and I'll wish that I could just tweak that wire back into the puddle, but you're helpless. But
right.
Now you've given me a joystick and the ability to move it in 2 axes.
Exactly. And you have direct feedback, so we have a Zyrus camera right here, and so we have a screen over there, and so you can see without even being in the cell, right here, right next to the business end, but we can do all that outside of the cell in a safe zone, and we can manually change that location and get the feedback from it. So.
Well, the third part of a welding video is the arc on. So let's step outside and light an arc.
Let's do it.
All right, so we've got an arc on. We're looking at it through the Zyrus camera. The old man that taught me says everything you need to know is in the leading edge of the puddle. I see that it's following nicely. It's not jumping. Looks like we've got good fusion. And we've got the tungsten here in the center. If anything, I would say the wire is too close to the tungsten. Can you move it back a bit?
Absolutely, I can. So.
That's plenty right there. That's almost too much.
Yeah. Right here, and I can move it.
Move it closer.
A little further
Look,
back.
And that's had an effect on the whole shape of the weld puddle, hasn't it?
Right.
This is a whole new set of variables we haven't ever been able to play with.
Definitely not real time.
No, not in real time. And so, can you move the wire back towards the wall?
Yeah, so.
Okay, now it's stable. We're getting good feed in.
Right.
So we're applying additional power through the hot wire, but that hot wire power supply has to have a place to conduct that electricity. That's why it has to hit the puddle.
Right.
So we've had a Zyrus camera in here. If I recall, you were the one working with it that gave us data back on puddle position and other dimensional data.
Yeah, we were able to get real-time feedback from the Zyrus camera and port it through the PLC, I believe over ADS, to get actual like bead width, so like the weld puddle width, and so you can determine like certain hot zones. So what's actually interesting is that now that we have control over the wire location, we could close the loop there and the actual feedback that we receive from the Xyrus camera, we could have that automatically control the wire position.
That's what I want.
Yeah, so it'll follow the hot zone of the arc, trying to keep it as centered as possible. But yeah, I mean, we have a new source of control, and the possibilities, we're just finding new ones for it. So it's really exciting.
That'll be fun, closing the loop with vision, though.
Right.
All right, let's mess it up, okay? It's running great, it's running stable, that's the way I like to see it, but let's move the wire closer to the tungsten and demonstrate what can go wrong. So if we move it closer and closer, what you're gonna do is, see, now you're starting to drip the wire off. You're not running any hot wire, so you're not getting any hot wire heat contribution. And so back in the old days, you'd see that, and you'd either have to stop it or live with it.
Right.
But now you can just move it back.
Yeah, so immediately I can just jog it back out.
Outstanding. We're only talking about maybe 60 thousandths, 80 thousandths of an inch.
Yeah, it's relatively small, and we can change the amount. The jog, it can be incremental as well, so it can be a set increment depending on what your set speed is at, or you can just have it at a very slow speed. Obviously, you don't want it to start jumping around back and forth, but we've done oscillating wire before. This is something that is effectively similar to that. We could be moving it wherever we want. To tie into a wall better, if you're doing like a 45, that would be interesting.
Yeah, reposition the wire each time.
Exactly, yeah.
Outstanding. That sounds like we've opened up a whole new.
It's cool. Yeah, I'm excited.
Yeah, all sorts of new variables. Well, but the last part of every good welding video is the smoking part. So let's go in there and take a look.
All right, let's do it.
We're back at the working end of the torch. Shut it down.
Let's do it.
Nice control shutdown with ramp. Well done.
Post flow.
All the good stuff.
Pulled the wire back out of the puddle as well.
That was automatic retract?
Yes, sir.
That's why we have servo wire feed?
Yes, sir.
So, if you agree with me that the combination of 11 axes of servo control, a large industrial robot, an infinite rotation 7th axis, and automated wire positioning might be beneficial in your project, give us a call. Arc Specialties thrives on problems.
Send us yours.